Example number 2. Match each graph on the grid with its equation below. Now here's a little hint. Do not choose common points. For example, if I were to pick the point 0, 0 and test them in each of these, they would for certain all be a part of each graph. So what I want to do is I want to pick points that are easy to substitute but are distinct. So for example, on graph B, I want to put in -1 and 3, so our test point. We'll put -1 and 3. On graph B, we'll find the point 1, 2. And on graph C, we're going to find the point 1, 1. So what we're going to do is we're going to test each one of these out. Y equals x, y equals 2x, and y equals -3x. And we're going to create a little bit of a grid here just to organize our work, because organizing our work is actually quite important. So if I were to put in -1 for this test point, if I were to put in -1, I should get out 3 for my y. So if I put in -1 for my x, so y equals x, but I'm going to put in -1, y equals 2 times -1, and y equals -3 times -1. Now, the point on graph B, so this is for graph B, the function or the equation that I put in the -1 for and I get the point 3 will be graph B. So y equals -1, nope, that's not right. Y equals -2, nope, that's not right. But if I put in y equals -3 times -1, I get 3. Ding, 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 ding. So this graph has the point -1, 3. So this is graph B. So since we've eliminated what this graph is, we don't actually need to substitute in for it anymore. So let's put in 1, 2. Now that is going to be on our graph A. So if I were to put in 1 for my x, I should get a 2. Okay, so y equals, well, 1. Nope, that's not it. So y equals 2 times 1, which is 2. Ding, 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 ding. When I put in 1 for my x, the y value that I get out is 2. So that means that this is going to be graph A. Woohoo! So I don't have to check in the next one, and I just know that the point 1, 1, which is on graph C, is x, y equals x. So if I were to label this a little bit better, I'm going to say that this is y equals -3x, this is y equals x, and this one right here is y equals 2x. You're noticing that this has a negative slope. There's a negative number. It falls from the left to right. So that's another helpful cue if you see x's and y's on either side, and the number that's attached to the x is negative, you know that it's going to fall from left to right. Whereas if you have, say, something like 2x positive, it's going to rise from the left to right. Example number 3. Which graph on this grid has the equation y equals 3x minus 4? Justify your answer. What's wonderful about all of these graphs, so I, and I, they all have distinct points. So what I'm going to do is I'm going to just look at the the y-intercept. Okay, so the y-intercept. So that means I'm going to substitute x equals 0. Now I have 3 different y-intercepts here. I have 0, 2, I have 0, 0, and for 3 I have 0, -4. So what I'm going to do is I'm going to substitute 0 in for my x, because that's all common, but they all have different they all have different y-intercepts. Okay, so if I were to plug that in, y equals 3 times x, which is 0 in this case, minus 4, I would say y equals -4. So the point 0, -4 is the one that's going to match up. Well, look at that. This one right here has the point 0, -4. The y-intercept is -4. So I know that graph I, which is just Roman numeral for 3, is y equals 3x minus 4. Alright, so let's summarize this. There's a lot to summarize, but I'll try to be quick with it. So in summary, use test points to see if a line or a graph and an equation match. It's usually easiest to put in your x values, but sometimes it's easiest to put in your y values. It just depends on the question.